Hello and welcome. Today we're doing a question from LeetCode 75. It's called smallest number in infinite set. We're going to jump right into it. You have a set which contains all positive integers from 1 to infinity. Implement the smallest infinite set class. Smallest infinite set initializes the smallest infinite set object to contain all positive integers. The popSmallest removes and returns the smallest integer contained in the infinite set. And addBack adds a positive integer num back into the infinite set if it is not already in that set. And we have example 1 here, and we'll take a closer look at that. But looking at the constraints, we know number is going to be between 1 and 1000, and there are only going to be 1000 calls made in total as well. So this is not truly an infinite set. We do have bounds, but to keep ourselves aligned with the true spirit of the problem, we're just going to assume it's still that infinite set. We're going to pretend this bound doesn't exist for solving the problem at least. So example 1, we first initialize our smallest infinite set, and this is going to hold all positive integers from 1 to infinity. So it's basically going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all the way through. Now we want to call addBack with the number 2. 2 is already in our infinite set, so this is not really going to do anything. It only matters if 2 had been removed by popping, at which point we would have to add back. So right now, addBack doesn't really do much. Now we want to pop the smallest, so our smallest number is 1. We're going to get rid of it, and we're going to return that. We call popSmallest again. We're going to return the next smallest number, which is 2. And we want to pop smallest for the third time. So right now, our smallest is going to be 3. We want to go ahead and pop it. So our next smallest would be 4 when we next want to pop it off. But before we do that, we do have an addBack. We want to add 1 back into our set. Now 1 is smaller than the current smallest we have. So we know the next time we pop, we want to pop off 1. So adding 1 somewhere back in here, right? We add 1 in our infinite set. When we call popSmallest again, now we're going to be popping off and returning that 1. So we're going to be removing this 1, and now what would the next smallest number be? And how do we actually find that out, right? Are we keeping our numbers that we have from 1 to infinity in some sort of array, a linked list? How are we ordering this? Are these all going in a heap? Remember, we do want to pretend this is truly an infinite set, so it's impossible to maintain all of these numbers, right? Instead, what we could actually do is keep track of all the numbers we have removed. So if we had a set keeping track of all the numbers we removed, in it, we would have 2 and 3. Now we know we just popped off 1, so the next smallest number should have been 2. Now if 2 is already in the removed set, we can't use that, so we want to check the next smallest number of 2. That would be 3. It's already in removed, we can't use that. What about 4? 4 isn't in this set. That means it exists somewhere in this infinite set, and that's what our next smallest number is going to be if we want to remove it in the future. So at this point, we only have 2, 3, and of course, since we did return our 1 with the popSmallest, 1 in our set. Now, once we call popSmallest again, we get rid of this 4, and we're going to add it to our set. Now we see if 5 exists in this set. It doesn't, which means our next smallest is going to be 5. So when we call popSmallest for the last time, we are going to be returning 5 as our output, adding it to our set. And since 6 doesn't exist in the set, our next smallest would be 6. So that's all we really need to do in order to solve this. Now, how would we code this up? Well, that's easy. We just need 2 fields. We need a variable keeping track of the next smallest number we have in our infinite set. So let's say self.smallest is going to start off with number 1, and we're going to have a set to keep track of all the numbers we have removed. So self.removed is going to be a set. Now, starting with addBack, what do we want to do for this function? We know there are going to be 2 choices, right? If we want to add back a number, either the number already exists or it doesn't. If it already exists in our set, say we wanted to add back 8, it's already in here, it doesn't really matter, so we're not going to do anything. But if we have already removed it, if it exists in self.removed, then we want to do something. So only if num in self.removed do we want to have some kind of logic, and what would that logic be? We're adding something back, right? So we're going to remove it from our removed set. It's no longer removed from the infinite set. So self.remove that number. And if that number we're adding back is smaller than what we have stored in self.smallest, we want to update our self.smallest. So if num is less than self.smallest, we are going to set self.smallest to be that number. And that's it for our addBack. Now, what about popSmallest? For popSmallest, we always store our next smallest number in this variable right over here. So that's the number we want to be returning. So returning is going to be self.smallest. Now that we know we are popping this number off, we want to add it to our removed set. So self.removed.add the number we're returning. And now we want to keep track of the next smallest number in our variable. So self.smallest plus equals 1. So we're setting our self.smallest to be that next number. But what if it's already in that removed set? Then we just want to keep looping through until we find a number that's not in removed. So while self.smallest in self.removed, if it's in that set of numbers we removed, we want to increment it by 1 each time. So self.smallest plus equals 1. And once we break out of this while loop, we'll finally have the next smallest number that hasn't been removed. So all we need to do is return our original number that we had wanted to return. So let's go ahead and submit this. We are getting the wrong answer. Let's see why that is. Oh, this is a typo over here. This should be smallest. And now let's go ahead and submit this. And it is accepted. So for space and time complexity, let's talk about time complexity first. What's it going to be? Well, let's look at each function individually, right? For the addBack, how much time would we be taking up? The first thing we do is check if something is in a set, self.removed, so that's going to be constant time. If it is, then we go ahead and remove something from our set also in constant time, and we're just updating a variable, so this is going to be O of 1. Now for popSmallest, what is our time complexity? We're taking what we have in a variable and we're looping through until we find the next smallest number that's not in a set. Now this on average, talking about amortized time complexity, will also be O of 1 because we could be adding something to our set and then popping off that smallest number. Going back and forth is going to be constant O of 1. And for space complexity, since we are keeping a set as well as one variable, we technically know we're not going to have more than 1,000 elements. So this is also going to be constant O of 1. So we just went ahead and solved smallest number in infinite set. If you have any questions, let me know down below in the comments. If this video was helpful, like, comment, share, and subscribe. It really supports the channel. And as always, I will see you in the next video.